Okay, so compound interest is just really should just be a review that you did last year, although you might not have gotten to that because some of us only got a couple units done. But compound interest is when interest is added on to interest. So I'm going to go back to this formula in a second. So I just want to compare the difference between simple interest and compound interest. So let's just look at this. So simple interest. And this board is off. Okay, so simple interest, we don't usually use simple interest. It's because it's interest that is added the same amount every single time. So simple interest, the formula is I equals PRT, where I is the interest that you earn. P is the principal, which means the starting amount. And R is the interest rates. Oops. And that's always a decimal, okay? And then T is time, and that's always in years. Okay? So simple interest, we add the same amount every time. And it's always determined, oops, that's not what I wanted. It's always determined by the original value. Weird. Okay, so it's always determined by the original amount. Right, so it doesn't accumulate, you just add the same amount every single time. Compound interest is A equals P 1 plus I to the n. So A is the amount. Right, so amount being the original amount that you started with plus the interest added on. Okay, which is different than simple interest. The I is just the interest. It's not the original amount, it's just the interest that you've earned on that amount. P is the same thing, principal. So starting amount. I is your interest rate. And N is number of. So we'll look at this in a bit more detail in a minute. Compound periods. Okay, so the difference between simple and compound is simple interest, you add the same amount every time. Compound interest accumulates. So the next time you're calculating it from the previous amount, not from the starting amount. So interest accumulates. And so generally when you have a bank account and savings, you're going to get compound interest. Interest is going to be added onto the interest. That's why they call it interest on top of interest. Okay, so here let's say this was simple interest and you started with $100. Okay, so when you calculate your interest, you would take the starting amount, $1,000. We're getting 5% interest. So we're going to multiply it by 0.05, and we're going to do it for 1 year, and you'd earn $50. Okay? So 1,000 times 0.05 times 1 is $50. So now you have 1,000 plus $50. Okay? So then the next year, you're starting with $1,050. You're still earning $50. Okay, it's still based on the original amount, not on this amount. Okay, so every time, every year, you're getting $50. Okay, so now you have $1,100. But the balance, the interest is calculated on the original $1,000. So you're getting another $50. So now you have $1,150. Interest is based on the original 1,000. You're getting another $50. And now you're at $1,200. So every single year you're getting $50. That's not going to change. Okay. The difference in compound interest is that when we calculate interest, so the first interest, we're starting with $1,000. So we're doing $1,000 times 5% by 1 year. You get your $50. You're at 1,050. Okay. But then the next time they calculate interest, they're calculating it on this amount, the $1,050, not the $1,000. So now instead of making $50, you're making $5,250. So you're making a bit more interest, and they're going to add that on to here. So now we have 1,102. So when I do I again, it's going to be 1,102.50 times 5% for a year. So now you're going to make a little bit more interest. So 1102.50 times 5%. So now you're making $55.13. Right? So the first year you made $50, the second year you made a bit more, $52.50. Now you're making $55.13. So that interest, when you calculate your interest, it's based on the previous year, not from the original. So that's the difference between compound interest and simple interest. Let's put that final amount here. So finally we have 1157.63. So you can see you earn more money with compound interest. If you were to graph these, the simple interest, you started with 1,000. The first year you had 1,050. Then you had 1,100. Then you had, and so with simple interest, you're going to get a straight line, right? Because you're making the same amount every year, up $50, up $50, up $50. Okay. With compound interest, you're going to get an exponential function. I'll just kind of exaggerate it here. So compound interest is an exponential function because you're getting more each year, and so it's going to go steeper. Okay. And you'll see in the formula there's an exponent, right? So compound interest is always an exponential function. Right? So this is linear, and this is exponential because you have an exponent, right? Power n. So instead of doing compound interest this way, where we add every year, we just use one formula, which is the a equals p 1 plus I to the n. Okay? So that we don't have to keep doing it every time. We just do it once. Okay. So I'm just going to add a page in here. So the two important things with compound interest, just as a reminder. Let's put this in here. Okay, so the important thing with compound interest is the I and the N. If anybody's going to forget to do something, it's always the I and the N. So we said A is the amount, P is the principal or start amount, I is the interest rate, so that always needs to be divided by how often you're getting that interest. Okay, so we'll look at some examples. So you could get it annually, right? If you had it annually, then you would get once a year. You could get it semi-annually. You get it twice a year. You can get it quarterly. You'll get it 4 times a year. You can get it monthly. You could even get daily. You could get weekly, right? 52. So that I has to be divided by how often you are getting that interest. So it'll be divided up. So maybe you get 12% for the whole year, but if you get it monthly, you're getting 1% every time. Okay, because they're going to divide that 12% up so that by the end of the year you get your 12%, but you're getting it every month. Or you could get it once in one big chunk, right? You could get the whole 12% at the end of the year annually. You could get, so let's say we had 12% annually. We could take that 12%, but if I get it every 6 months, then I'm going to get 6 months in the first half of the year, and I get, or 6% in the first half of the year, 6% in the second half of the year. So by the end of the year, I get my 12%, right? If I got that same 12% and I got it quarterly, so by the end of the year, I have to get 12%, but I'm getting it quarterly, so every 3 months, right? Then that 12 is going to be divided by 4. So that means every 3 months, I'm going to get 3%, so that by the end of the year, I get my 12%, okay? So that's what the I, that's the most important thing with the I. The N is the number of compounding periods, which means how often we're getting interest. So for example, I could get quarterly for 5 years, would be 4 times a year for 5 years. I would get interest 20 times, right? I get 4 the first year, 4 the second year, 4 the first year, a third year, and so on. I could get monthly for 3 years. So it would be 12 times a year for 3 years. It's 36, okay? So the I and the N are the most important part of the question. Okay, so $8,000 is invested for 6 years at 5% compounded annually. Determine the amount at the end of 6 years. Okay, so my original amount that I'm investing is $8,000. Okay, so I'll just put the formula up here. Okay, so the 1, because amount is your amount invested plus your interest, the 1 is representing the original amount, right? Because if I do the original amount times 1, so if I do P times 1, I get P, right? So that's why the 1 is there. So the 1 is there because the end amount is the original amount P plus interest, right? So then that's added on, and then we're going to do that a certain number of times. So I would suggest you always write it like this. Start amount 1, put your interest rate as a decimal, so 5%. And then always divide by how often it's compounded. So this one is compounded once, so I just divide by 1, okay? And then N is once a year, and we're going to do that for 6 years. So N would be 6, okay? So it's always how often and how many years. And then I just type it into my calculator. So you can type it in as it is. I'm going to add the 5% to the 1. I'm going to do the exponent first, and then I'm going to multiply by $8,000. So I end up at the end with 10,720.77. Let's take that out. So it is 1 times 6. So how much interest did I earn? If I want to figure out how much interest I earned, I just take the end amount and I subtract what I invested, and that will tell me how much interest I earned. So over 6 years, I earned $2,720.77 interest, okay? And then the 8,000 was the original investment. Okay, so let's do number 2. I'm going to do number 2 on a different page because I don't have any room here. So number 2, we'll just write our numbers here. So number 2, we are investing $10,000. And the interest rate is 6% and it's compounded quarterly. So it's 6% compounded quarterly. And then N is quarterly. And then it is invested for 4 years. Times 4 years. Okay? So when I'm doing my formula, I am investing $10,000. 1 plus, I write the interest rates, and then I divide it by how often it's compounded. So divided by 4. And then my N will be quarterly, 4 times a year for 4 years. So I'm getting interest 16 times. Okay? And then you can just type it in as it is in your calculator if you want. You can divide the interest first. So I could say, okay, 6% divided by 4 is 0.015. Right? So I could do that first if you want. And then you can just type it in. Okay? So $10,000 times 1.015. Just be careful with your decimals. So power 16. And at the end, that's how much money I have at the end. So I've earned $2,689.86 interest. Okay. These questions that I have here are from your guide, right? So they're in the guide. So I'm just kind of going through them. 5 years ago, you had invested money at 7%. The investment has a value of 9,000. How much did you invest originally? So in this question, you're looking for P. Okay. So they're asking you what did you start with, and now you have 9,000 at the end. So number 3, it has 9,000 at the end. P is what you want to figure out. At the start, it's 7% compounded semi-annually. And N is semi-annually. And it is for 5 years, right? 5 years. So N will be semi-annually, so twice a year for 5 years. So N will be 10. Okay. Okay, so this time we know the end amount and we're looking for the start amount. And we are getting 7% compounded semi-annually, so we're going to divide that by 2, and our N is going to be 10. So 0.07 divided by 2 is 0.035. So if I want to find P, what do I have to do? If we want to isolate for P. So this goes back to your rearranging equations. What operation is between P and the bracket? Is it add, subtract, multiply, or divide? Multiplication. So what do we have to do to inverse that? It's the opposite of multiplication. Divide, right? So if I want to find P, I'll have to divide. So I'll have to divide to get rid of this, right? We don't want that there. We want it over here. So I'll have to divide to get my answer, okay? So that's why solving That's why solving is important, because we'll need it to solve certain equations. So this time I am dividing 9,000 divided by 1.035 to the power 10. So do you think my answer will be more than 9,000 or less than 9,000? Less, right? I should start with less than what I ended with, right? Because I've earned interest. So my answer should be less than 9,000. If it is more, I know I did something wrong, right? I can't end up or start with more than what I end up with because I've earned interest, unless it's a loan, right? Okay, so you might have to be determining A, or you might have to be determining P, right? One or the other. So if it's A, you multiply. If it's P, you divide. Okay. Just going to look at this for a second. So we did that one. Find the future amount. So this one, you're looking for A. This one, you're looking for P. And this one, how much money we need to deposit today. So 4, you have to find A, and 5 and 6, you have to find P. Okay? One thing I also wanted to show you, because we're going to use this with the more specifically with the annuities, which we're going to do on Friday, but I want to show you now because you're here. Okay, the TVM solver. So you can type in this into your Google. Okay, I'll just write here. So the one you want to use is this one. So you're going to type that into Google. You'll see TVM solver GeoGebra. I'm just going to bring the screen up here. Okay, so this is what it will look like. So this does calculations for you, right? It's normally we would have these, in the past we would have these graphing calculators, and we'd have a class set and then you could use them in class, but we don't have enough anymore. But this has this is on this, right? It's a financial application, but you can Google it now and just use it. So it's a fast way to do questions and just check your answer. So you will be required to do the calculation and show your work, but this can check your answer. So N is the same, right? N is the same as it is in compound interest. I is the same. So with the I, you don't have to divide it, right? You know how we divide it by compounding? You don't have to do it. The calculator will do it for you, okay? So we don't divide by compounding. PV is your P. So PV stands for present value, so your principal. Payment, don't use. We're only going to use this for annuities. So a payment means when you're making a regular payment, like maybe a loan, or maybe you're making a regular deposit. So it will be 0 for compound interest, okay? FV is your future value, which is your A. So future value is the amount at the end. And then PY, CY should be the same. This is your compounding period. So PY is payments per year. And CY is compounding per year. So for compound interest, they should be the same. 1 would be annually, 2 would be semi-annually, 4 would be quarterly. Okay, so if we do that previous question, okay, so I'm just going to, let's do question 2. So question 2, we invested $10,000 at 6% compounded quarterly for 4 years. So we invested $10,000. So I'm going to put, oops. Present value was $10,000. So $10,000 at 6%. So I'm going to put in 6% for the interest. N was, what was it, quarterly? So it was quarterly for 4 years, right? So N was 16. Let's make sure I get this right. Okay, so N was 16. It was quarterly for 4 years. Payment we said was 0. Future value is what we want to find. So PY and CY would be 4. Oops. Okay, so it's quarterly, so compounding is 4, right? And I'm getting my interest 4 times a year. I'm getting it 16 times, 4 times a year for 4 years. My interest rate was 6%. I don't have to divide that because the calculator will do what I say here, right? So whatever interest rate, it will divide it by whatever this is. I'm investing $10,000 and I want to find my amount at the end, future value. So I just go to solve for future value and I get my answer. Okay, so $12,689. If I look at that question, we got $12,689. Okay, so it's a good way to check your answer. It's an easy thing to use. If we do this one we wanted to find P. So it was 9,000 at 7% compounded semi-annually for 5 years. Okay, so semi-annually for 5 years, our N was 10. It was 7% interest rate. Present value is what we wanted to determine, right? So we put 0 in there. Future value, I had $9,000 at the end, and it was semi-annually, so these are 2. And then I wanted to calculate present value, so I solve for present value, and I get my $6,380, which was what we got here. Okay? So it's an easy thing to use. There is some decimals here. You can see the decimals right there, dollars and cents. So it's an easy thing to use to check your answer, right? You just type in what you know and then click on what you want to find out. But as I said, with a task or a test, you will have to show some of your work with the written response. You'll need to show the formula and what you put in, and then you can double check it with this if you want to use this. This is useful for annuities that we're going to do on Friday. So annuities, let's say you wanted to buy a car and you wanted to figure out what your car payment was. You could put in the interest rate that you're going to get the loan for. You could put in how much the car is worth, right? Your future value would be 0 because you want to pay it off. You can put in how many times you're paying your car payment, so it's usually monthly. So you put in 12, and then you could just click on here, and it will tell you what your car payment would be for a month. So you can figure out whether you can afford it or not. You can use it for mortgages, right, to see how long it would, what a mortgage payment would be, how much house you could afford to buy. It's useful for that. So these are good things to use, good tools to use. If you went on a real estate and you looked at a house, they actually have this on that site. They will say calculate your payment, and this is what they're doing, right? They're putting in, you know, how much is the house, what's the interest rate, how long do you want to take to pay it off, how often do you want to pay it, and then it will tell you. And that's exactly what this is, okay? So